Okay. Eldar, Elshan, can you turn on your camera or?
Do we have to?
Yeah, if you can. If you have
Okay.
good internet connection, just for introduction, and after that, maybe sometimes you can turn it off. Okay. Elshan, welcome. I think this is your first class here with us, right?
Yeah.
You are grade 9 student?
Yeah, I am.
Okay, very good. How about Eldar? Can we see your face? Okay, maybe he cannot hear us. Okay. Uh, okay, now we can see Eldar's face also. Eldar, welcome. Guys, nice to meet
Hi.
you once again. Okay, so this is our intensive math class. This is level 3. Um, in this group, we are 3 students so far. And since you are new students, let me just tell you briefly about how we are conducting this online class. Okay,
Hello,
hello.
hello.
Yes, Elshan, do you hear me well? Is it
Can you
clear?
hear me?
Yes, I can hear you.
Um, I can hear as well. Everything.
Okay. Arad, I can hear you. Can you hear us?
Yes.
Okay, very good.
Teacher, should I send the homework?
Say again?
Should I send the homework and the test?
Yes, of course. If you finish, you have to send it immediately once it is done. You don't have to wait, okay?
Okay.
Okay. Elshan and Eldar, we have a WhatsApp group, okay? We communicate each other through that WhatsApp group. And here, as you see, our class is intensive math lesson, or let's say online class. So that means that you know your responsibility and you want to learn more. I think that's why you are here, and you have responsibility and I have responsibility. Okay, so how it goes, actually how it works here, I'm going to teach. After that, I'm going to send you some homework assignment. You should do this on A4 size paper. Okay, and using that camera scanner, let me just write here, camera scanner, cam scanner in Android, also in Apple Store. You have to download this app. Using this app, you can take or scan your work, okay? And after that, you can save it as a PDF file and put your name, and you have to send it back to me through WhatsApp. That is how you actually do your homework. And during the homework, if you don't understand any questions, you can bring your questions here. We may have discussion together and I'll try to answer your questions. Okay. Number 2, at the end of, like, let's say 3 chapters, after we cover 3 chapters, you are going to have like 2 or 3 tests. Okay. And also tests, you need to, if possible, print out. Okay. And you have to do this and send it back to me. Okay. Who is writing this? Arad, is it you?
And no.
Okay. Okay,
It
Elshan and
wasn't
Elda.
me.
And as we actually go through these classes, maybe after 2 and 3, you'll understand more and more. And this is my WhatsApp number. Maybe you should add it if we continue here. 855-959881. Okay, that is 955 9828. Here we have 2881. Okay, and there we have Sasmo group. If you just say hi and mention your name, I will add you to this group, Sasmo grade 9. Okay, it's just a group name, and once again, we are not only learn math for SASMO, okay? You are learning math, number one, to improve your problem solving skill and also for your future. After all, when you go to university, right? Now these days, any major that you're going to study, actually math, you will need math. And also, if you're really good at math, you'll see that actually you can learn other stuff, anything related to math much faster than other people, than other students, because it improves your analytic thinking skill, problem solving uh, solving skills, and also you can actually see connections between things very fast. Okay, that's why here we are just sharpening our knowledge and improving our problem solving skill. And also, since English is not your mother language, at the same time, by solving more different types of questions, and also you improve your vocabulary and also your English. Okay. Excuse me. And Elshan and Eldar, this is a private class. So if you have any question anytime, you can just raise your hand here. Okay, just stop me and ask me, and I'll try to answer your question. Okay, if you just keep quiet here and listen and I just talk, it may be a little bit boring. Anyway, in a week we have 2 day class. Okay, each day we have 1 hour class, and during the each session we have 5 minute break. Okay, we are going to have class like 30 minutes. After that you're going to have break for 5 minutes, and after that we will continue maybe 30 more minutes, and then we will finish our class. So far, Elshad and Eldar, with Arat, we actually covered 2 topics. Number one is um, solutions to quadratic equations. Number 2 is exponents or surds, indices, and the surds. Okay, all actually everything is in WhatsApp. You can have a look, and if you are interested, you can do those assignments once again, or you just continue from here. After we finish this chapter 3, I will send you a test. Okay, so you have to do it and send it back to me again. All right, let's continue. Today's topic, linear inequalities. Okay, it's very easy topic, but it's really important to understand how we solve in general inequalities. It can be quadratic inequality, it can be logarithmic inequality, it can be trigonometric inequality, anything. But to solve this, you need to have some idea about inequalities. So here we are going to start with linear inequalities, and after that, maybe a bit later, we are going to see more complicated problems involving inequalities. Okay, so what we are going to cover here, number one, is solving linear inequalities. If you are given linear inequalities, how do we solve this? And how we present the solution sets. Okay, as you know, when we solve inequalities, we can actually display the solutions in 3 different ways, and we are going to see this. One is set form, another one is illustrating your solution on the number line, and what is it, just algebraic inequality, or using algebraic way, and problems involving linear inequalities and linear inequalities in one variable. That means systems of linear inequalities. Okay, before I continue, let me just draw one line, because otherwise it will be messy. Okay. All right. Okay. So first, let's start with the definition. What do we mean by linear inequality, right? Actually, from math, we know what is linear equation, because we know that ax plus b is equal to 0. We call this linear equation in one variable, right? So here we are going to talk about linear inequalities. Instead of this equal sign, if I put either this greater than, or I can put any inequality sign. We have 4 inequality signs, right? Number 1 is greater than, second one is less than, third one is greater than or equal to, the last one is less than or equal to. Actually, any algebraic expression that involves one of these symbols, it's called inequality. And particularly if our expression is something like this, we call this linear inequality, right? And the solving is exactly the same, very similar to solving or is it linear equation. To do this one, we have to isolate x, right? The first step, we should take this b to the right hand side, that is negative b, and after that I should also eliminate this a from x. How can I do that? At the time, it depends on the sign of this a. The first case is here, let's say a is positive. At the time, I can divide both sides by a, right? Nothing changes here, minus b over a. So a cancels out each other. X is greater than minus b over a. That is the solution, right? In another way, how can we show this solution on the number line? I can draw a number line here. Let's actually plot this point. Since they don't have equal sign, I just draw empty small circle. Let's say this one is b over a. So x is greater than, that means all the numbers to the right of this number. It will be the solution set of this inequality. And the third way, that is the first way, that is the second way. And how about the third one? Set form, in solution set form, you can just write it as minus b over a to positive infinity. And what is the difference between equation and inequality? Usually inequality has infinitely many solutions, right? And equations may be a lot of solutions, but usually it has a few solutions, maybe one. If it's linear equation, maybe one solution. Quadratic equation, maybe two solutions. But inequalities, we have a lot. In daily life, actually, we use this also a lot, right? For example, let's say to be eligible to vote for a president, right, your age must be at least 18 years old. What does it mean? If your age is, let's say, Y, then at least 18 years old means that your age is must satisfy this inequality, right? So if your age is 19, then you are eligible for voting. If you are 20, it's okay. But sometimes also when you're watching TV, you will see a kind of announcement, right? That is for the people who are under 12. Under 12 means that is X less than or equal to 12. Since we are talking about the age, also we know that the X must be greater than 0, right? For example, let's say there's a special carton for only kids under the age of 12. Anyway, we are going to see this kind of examples. Another case here, let me just finish this part. The only difference between solving equations and inequality, how about in this case, if our a is negative, what happens here? Like, for example, let's say 3x is less than 6, for example, right? At the time, if we divide, here we have ax is greater than negative b. If you divide both sides by negative number, or if you multiply both sides by negative number, at the time we need to change this inequality sign, right? The direction of the inequality sign. So if I divide both sides here, then here we have ax over a. Here we have minus b over a. Since here a is negative, so actually we need to change this negative sign. So now they cancel out each other. So x is less than minus b over a. Okay. Or on the number line, here we have minus b over a. X is less than this number. So all the numbers to the left, right? I can just show this. Yeah, also in different way we can show this, but here and I just prefer to do like this. And how about solution set, or in set form, solution set will be from minus infinity to minus b over a, right? That means that if you just pick any number from this interval, or any number from here, or any number from here, right? That means that it satisfies our original inequality. That is our original inequality. Okay, let's see a few examples that are just how to show this on a number line. We'll talk about this a bit later. Okay, and these are just general rules. Solve the following inequalities. Okay, Elshan, Arad, and Eldar, once again, these are, I'm not teaching here because you don't know. I'm sure you know these things, okay? It's very easy, but you have to be familiar with the concepts, okay? And also just revision. I'm just cover this maybe in 1 hour, we will finish, and we will continue with other topics. So the first one, x plus 3 is less than 7. So the answer is x is less than 7 minus 3, that is 4. Or in solution set form, what is it? It is from minus infinity to 4. How about B? 2x minus 1 is greater than 5. So 2x is greater than 5 plus 1, that is 6. X is greater than 6 over 2, it is positive, so we don't have to change this inequality sign, that is 3. Or in set form, what is it? It is from 3 to positive infinity. How about C? Here we have 6 minus x is greater than 4. First, we have to eliminate this 6 from the left-hand side. How can I do this? Just take to the right-hand side or subtract 6 from both sides, right? Actually, it gives the same result, minus x. So here we have 4 minus 6. Or if you simplify this, we get negative x is greater than 4 minus 6, that is negative 2. So now I want to have x here, right? Because we are trying to isolate x here. So to get x here, we should multiply both sides by negative 1. If you multiply negative 1, just 1 second, I need to answer this phone. Alo. Aha, Elşan, bir de Eldar. Şu an Arat var. 3 kişi var. Tamam. Aha, oldu hocam. Okay. So if we multiply by negative 1, right, since we're multiplying by a negative number, also we have to change this negative sign. Negative 1 times negative x, that is x, and less than negative 1 times negative 2, that is 2. So that is the answer. Or on the number line, here we have 2, not inclusive, right? It doesn't actually include this boundary point. So that is the solution set. Or in set form, that is from minus infinity to 2. Arat, is it clear?
Yes.
It's so easy, right? It's just we need to have a we need to make a quick revision. And I'm sure you studied this topic before. How about this? Is it recording? Yes. All right. Solve the inequality. So it's like solving linear equation. First, we have to expand on the right-hand side. So here we have 2x minus 3 is greater than 2 times 1, it is 2, minus 2 times x, it is 2x. So now take 2x unknowns to the left-hand side, constants to the right-hand side. So here we have 2x plus 2x is greater than, here we have 2, negative 3, take to the right-hand side is plus 3, right? 2x plus 2x, that is 4x, is greater than 2 plus 3, it is 5. And divide both sides by 4, so x is greater than 5 over 4. Or solution set, that is from 5 over 4 to positive infinity. Okay, how about example 3? Here we have fractions. Let me multiply both sides by 12 because 12 is least common multiple of 3 and 4. Multiply by 12, so here we have 4x is greater than, multiply by 12, here we have 3. 3 times x, it is 3x, minus 3 times 1, it is 3. Take 3x to the left-hand side, so 4x minus 3x is greater than negative 3. 4x minus 3x, that is x, is greater than minus 3. Or solution set, it is from negative 3 to positive infinity. Or on the number line, if we are asked to illustrate our answer on the number line, here we have negative 3, all the numbers to the right of 3, right? It will be actually the solution of this inequality. Eldar, are you there?
Yeah.
Is everything okay?
Yes. Yes.
So Eldar, what grade are you now? Grade 9?
Oh yeah.
Okay. All right. Now, how about if we have this less than or equal to, or greater than or equal to? How do you show the solution at the time? Actually, the only difference is this less than or equal to or greater than or equal to. That means that also we have to contain the boundary point, right? For example, in this example, take negative 2x to the left-hand side. So here we have x plus 2x, negative 7 to the right-hand side, less than or equal to 5 plus 7. So here 3x is less than or equal to 12. Divide both sides by positive 3. So x is less than or equal to 4. So that means on the number line here, since we have equality here, that means that also we have to include that point. So here we have 4. We have to draw here shaded small circle, and to the left, right? Because less than. So that is the solution set. So how about the solution set in set form? That is from minus infinity to 4 inclusive. So when we have equal sign, here we need to close this with bracket, right? Or rectangular bracket. That's the only difference. Okay. Another example, solve the inequality. Here we have the fractions 2 over 3, 1 over 2. So let's multiply both sides by positive 6. 6 times 2 over 3, that's equal to 4x minus 2 is greater than or equal to 6 times half, that is 3x minus 3. So let's expand both sides. Here we have 4x minus 8 is greater than or equal to 3x minus 9. Or 4x minus 3x is greater than or equal to negative 9. Take negative 8 to the right hand side. That is plus 8. So x is greater than or equal to negative 1. Or on the number line, if you illustrate the answer here, here we have negative 1. All numbers to the right of negative 1 will be the solution of this inequality. Or set form, it is from negative 1 inclusive to positive infinity. Okay? Okay. Elshan, do you have any question? Is it clear enough?
No, yeah, I got everything.
Say again.
No, I don't have any questions.
But do you understand everything? Is it too easy for you, or is fine, or
It's fine. Kind of a bit easy, I guess.
okay, good. Now let's see a few problems involving linear inequalities. Okay, in this section, we shall look at how inequalities can be used to solve problems. Very simple problems. Uh, okay, so here that example is from tennis. Actually, I put this example because I play tennis. All right, and we know that tennis is a game played by 2 people or 4 people, right? If 2 people they play against each other, we call this singles match. If 4 people, two actually they play against each other, we call this game doubles match, because 2 people are playing against 2 people, right? That is doubles match. Okay, in tennis, for example, if 2 people are playing against to each other, let's say this is A and this one is B. Okay, so actually we had different tournaments, of course. Sometimes, usually, they just play best of 3 sets. Okay, that means that maybe you need to play maximum 3 sets. Who takes 2 sets, he's a winner. Okay, so in one set, let's say in one set we have 6 games. All right, 6 games, and here if you take 6 games, then that means that you win the first set. Anyway, so Andy and Tony usually play tennis on weekends. Last Saturday, Andy won 3 more games than Tony, but together they played less than 11 games. Okay, what are the possible number of games Andy won? So here, let's say Andy won 3 more games than Tony. This one is Andy, this one is Tony. If Tony actually won 3 games, Andy should have won n plus 3 games, right? Because it says that 3 more games than Tony. And but together they played less than 11 games. So that is together n plus 3 and plus n is less than 11 games. So what are the possible number of games Andy won? To answer this question, we should solve this inequality. N plus n, here we have 2n plus 3 less than 11. or 2n less than 8. What is it? N is less than 4. So what is it? What are the possible number of games ND? One possible games for n is, what is it? It is possible solution for n is maybe 0, maybe 1, maybe 2, 3, right? These numbers are non-negative, what is it? Integers less than 4. Okay, since n this game is n plus 3, so possible games is, it is 3, 4, 5, and 6. Maybe Andy wants 3 games or 4 games or 5 games or 6 games. Okay, that is one actually simple example for a word problem that involves linear inequality. Let's do this question. Eldar, can you read the question?
Yeah, in 2004, 40,
A bit louder,
48,000.
Eldar. Can you read a bit louder, please?
Okay, 48,000 students from all races in Singapore received educative merit bursary awards ranging from 150
Ranging
dollar
from.
ranging from $150 for a primary pupil who to $400 for a pre-university pupil. These awards were given to the top 25% of pupils from each school. 8 of Mr. Ong's grandchildren received the EduSave Merit Bursary Award in 2004. Find the value of the largest and smallest possible amount that could be paid out to Mr. Ong's grandchildren.
Okay, thank you very much, Eldar. Sometimes, to ask one question, because if it is a real life problem, they need to tell the whole story. But actually, when you are solving, we may not need all the information given in the problem. And that's why you have to just pick keywords. Okay, what are the keywords here? Then using these keywords, we can model our question or problem. Then after that, we can solve this problem. So because here we have a lot of additional information, but actually they don't actually make any contribution to solution of this problem. So that's why we need to just pick keywords first. In 2004, 48,000 students from all races in Singapore received EduSave Merit Bursary Awards, ranging from $150 for a primary pupil to 400 for a pre-university pupil. Okay, what does it mean? It means that the government is saying that, okay, this year we are going to give some, let's say, prize, okay, or award for the students who achieved well in their studies. If you're a primary student, you will receive this much if you're a good student at your school. And if you are maybe high school student or secondary student, maybe it is more than 150, less than 400. And if you are a pre-university pupil or student, you will get this much award from the government because of your good performance. Okay, these awards were given to the top 25% of pupils from each school. All right. Eight of Mr. Ong's grandchildren received the EduSave Merit Bursary Award in 2004. Find the value of the largest, the first one is the largest, and the smallest possible amount that could be paid out to Mr. Ong's grandchildren. Ara, did you understand the problem?
So.
Okay, here, that's it.
I didn't
So,
send the of 8.
huh?
I didn't send Mr. Ong's 8. 8 of us.
Okay, there's a guy here, Mr. Ong, okay, and he has 8 children, actually not children, his 8 of grandchildren. They received this awards, okay, because they were studying well at their schools and they received these awards. But these students, are they from primary school or secondary school or high school or college? We don't know, right? So that's the question. Find the value of the largest and smallest possible amount that could be paid out to Mr. Ong's grandchildren. Okay, and we know the A student gets minimum $150 if he studies at primary school and gets maximum $400 if he is or she is a pre-university pupil or student. How about if you are between these two schools, maybe secondary school student, or maybe you're grade 8, maybe grade 9 or grade 10, not grade 11, for example. So your award is something between these two numbers, right? Maybe 200 or 300, we don't know. But what we know here is your award is more than 150 and less than $400. Okay, so now we have to consider these two extreme cases here, right? Since here Mr. Ong has 8 children, each one gets reward. Now minimum, how much does he get? Let's first find maximum. So when actually these people get maximum award, if all of these students are pre-university students, right? At the time, each one gets $400. So that means that Mr. On student altogether, they will get $3,200. And how about minimum amount? Let's say all of his grandchildren, they go to primary school and they are good students at the time, each one receives $150. So here we have $150, that's equal to $1,200. Now, how about other cases? Maybe some of them are primary school students, some of them are secondary or high school. At that time, it will be that the total amount will be between this minimum and maximum. It will not be more than 3,200. It will not be less than 1,200. So maximum possible amount that should will be given out to Mr. Ong's children is $3,200, and minimum amount that may be given out to Mr. Ong's grandchildren is $1,200. Elshan, is it clear? Did you understand?
Yeah, I understood.
Good. Very good. Let's try another question. Elshan, can you read the question problem and we will solve it together?
Kumar scored 66 and 72 marks respectively for his 2 class tests. What is the lowest mark he must score for the third test if an average score of at least 75 is required?
Okay. There is a bonus prize for the students. Okay. To get this bonus prize, your average must be at least 75, right? So your first test result and the second test result, they already came out. So here, actually, you're expected to take 2 or 3 tests. The first one already came out. You got 66. And the second test, you got 72. But third test, still, we are not sure. We didn't take it yet. Okay. And in the announcement, it says that if your average is at least 75, then you will qualify for a bonus prize, right? So what is your average score here? To get the average score, we had to add them up together, 66 plus 72 plus n, and we should divide it by 3, right? If you have 4 people, add 4 numbers together, divide by 4. If we have n numbers, add them together and divide by n, it gives us the average value. So actually it says that at least, that means that this should be greater than or equal to 72, right? Because if your average score is 72 or more than 72, then you will qualify for a bonus prize. So that's it. That's the most important thing. Once you actually get your inequality, just solve it and we'll get the answer. From here, 66 plus 72, that is 138. 138 plus n, multiply both sides by 3. 3 times 2, 6. 3 times 7, it is 21. From here, what is n? N is greater than or equal to 216 minus 138, which is equal to 62 plus 16, that is 78. So n is greater than or equal to 70, 78 or 88? 62. Okay. Yes, Yashan?
But it says the score should be at least 75, not 72
Or 75. Someone, thank you. Thank
in
you.
the problem. Yeah.
This should be 75. Okay. At the time, here we will have 225. And here we have 225. And that is
8.
6287. Right? Okay, now what is our answer? Now we should write here Kumar should actually should score at least 87 in test 3, right? To qualify for a bonus prize. So if he gets at least 87 in the third test or in test 3, then he will qualify for a bonus prize. Okay? This is how actually understand the problem, because as you know, this kind of problems, if you don't understand the problem, you cannot solve this. That's why understanding is really important. I mean, to understand fast, actually we need to solve some different types of problems, so that when you have a look at the question, the idea comes immediately. You can visualize what you're talking about here. Okay, another example, and after that maybe you'll have break for 3 minutes. Arat, it's your turn. Can you read the problem?
Admissions test consists of 20 multiple choice questions. 3 points are awarded for a correct answer and 1 is deducted for a wrong answer, while no point are awarded or deduced for an unanswered question. A boy attempted a total of 19 questions and his total score for the test was about 32. Find the minimum number of correct answers to be obtained.
He obtained, right? Find the minimum number of correct answers he obtained. That means that how many questions did he answer correctly? That's the question. So here we are talking about a math test that contains 20 multiple choice questions. And it says 3 points are awarded for a correct answer and 1 point is deducted for a wrong answer, while no points are awarded or deducted for an unanswered question. Okay, so that means we are talking about uh, multiple choice question. Altogether, we have 20, right? Here we have 3 possibilities, right? We have 3 possible cases. Number 1 is when your answer is correct, maybe it is wrong or unanswered. Let's say it is, you just left it blank. If your answer is correct, then for each correct answer, you get 3 points. If your answer is wrong, then you get -1 point. Deducted 1 means that is -1, right? We subtract 1 from your total score. And if you just leave it blank, that means that no point is awarded. So just 0. Continue. Next part. A boy attempted a total of 19 questions. What does it mean? He just left 1 question blank, right? 1 question blank and 19 questions he tried. And his total score for the test was above 32. Find the minimum number of correct answers he obtained. Okay, let's say he answered n questions correctly. At that time, how many questions will be wrong here? Here there will be 19 minus n, because these things altogether is equal to 20, right? 1 left blank, so 19 questions left, and n out of 90 questions it was correct, and how many would be wrong? 19 minus n. So here it says that the test was about 32. So how do you calculate his score here? For each correct answer, he got 3. So here we have 3 times n plus, and here we have 19 minus n. For each wrong answer, he got -1. And for blank answer, he got 0. And his total score, that's the total score, it's above 32. So it was greater than 32. So if we answer this inequality, we will get n, right? It says find the minimum number of correct answers he obtained. So from here, 3. And 19 times negative 1, that is negative 19. Negative 9 times negative 1, it is positive n, and here we have 0. Is greater than 32. 3n plus n, that is 4n. Take 19 to the right hand side. 32 plus 19, that is 51. Or n is greater than 51 over 4, which is equal to 12.75, right? 51, because 48 is divided by 4, it is 12. 3 over 4, that's equal to 0.75. And we know that we are talking about the number of questions, right? So it must be a whole number. So from here, what is the smallest number that is greater than 12.75? On the number line, here we have 51 over 4. The smallest integer greater than this number is, what is it? It is 13, right? So find the minimum number of correct answer he obtained. So we should write here, answered, he answered at least, at least 13 questions correctly. Okay, good. Guys, you want to have some break? Let's have break for 4 minutes. Okay, after 4 minutes, we will continue. And we have 22 more minutes. And after that, I will finish the class. 4 minute break. Okay. We will finish class in 20 minutes. Okay, or maybe 15 minutes. Okay, it's because it's 1 hour class. So we will finish after 15 minutes. All right. Now let's talk about linear inequalities in one variable. It's like solving linear equations in one variable. Okay. So if given two or more linear inequalities which are connected by the word and, the solutions to each inequality must satisfy all the others simultaneously. So in other words, only the common solutions of the inequalities should be considered. So that means that if you're solving maybe two inequalities together, or three inequalities together, or five inequalities together, in general math, what is the solution of this system? We need to pick the common part, right? It means that, let's say, again, it's like a set. So here we have the solution of the first inequality. That is the solution of the second inequality. And what will be the solution of both inequalities? We need to take the intersection part, right? Also, it's like solving inequalities. Let's say here, the solution of the first inequality is here. Let's say the solution of the second inequality is here, for example. Where is the common part? Here it is a common part, right? If you just pick these numbers from here, actually these numbers satisfy both inequalities at the same time. But here it satisfies only one inequality. Here, one inequality. That is the main idea. Okay, let's just see this in examples. Solve the inequalities. 3x plus 4 is greater than 13, and 4x minus 13 is less than 11. So to solve this one, we have to solve them together, right? One by one. The first inequality is 3x greater than 9. So x is greater than 3. And how about the second one? 4x is less than 24. X is less than 6. So on the number line, here we have 3, right? That is greater than 3. Let's say this, these numbers. And the second one, here we have 6. It is less than 6. Actually, we are talking about these numbers, right? So where actually we have number that satisfy both inequalities? Here, right? And also from here, x is greater than 3 and x is less than 6. If I combine these two inequalities, we get this inequality, right? X is greater than 3 and less than 6. So that is the solution of this inequality. Or in set form, solution set will be, what is it? From 3 to 6. And this is how we solve a system of linear inequalities. It can be 2, it can be 3, it can be 4, it doesn't matter. Another example, Find the integer values of x for which 3x is less than or equal to x plus 6, and 2x plus 4 is less than 3x plus 6. If you saw the first inequality, we have 2x less than or equal to 6, x is less than or equal to 3. If you solve the second one, take 3x to the left-hand side. That is 2x minus 3x less than 6 minus 4, or negative x less than 2. Multiply both sides by negative 2. So x is greater than negative 2. Okay? So now if I just combine this, x is greater than less than or equal to 3, x is greater than negative 2. Well, that means that if you just combine this, the solution will be, what is it? Minus 2 less than x less than or equal to 3. So on the number line, here we have negative 2, not inclusive. Here we have 3, inclusive. What is the question? Find the integer values, right? What integer do we have here? Here we have negative 1, here we have 0, here we have 1, here we have 2. So the solution set is asking only integer solutions. It will be negative 1, 0, 1, 2, and 3. These are the solutions of this inequality because it's asking integer values only. Okay, good. All right, two more examples. Example 11, solve the following inequalities. Now let's solve a bit faster. The first one, it is 4x minus x. It is 3x greater than 5 minus 9. It is minus 4. So x is greater than minus 4 over 3. It says just solve the following linear inequalities. And how about the second one? It is 2x is less than or equal to 11 minus 17. That is minus 6. X is less than or equal to minus 3. Okay, so if you draw a number line, we are talking about the first one. Here we have negative 3, and here we have minus 4 over 3. The second one is less than or equal to negative 3. It is here, right? We're talking about this. How about this one? The first one, x is greater than minus 4 over 3. So it is here. Do we have any double shaded area? They don't have any common part, right? So that means that the solution set here, it is empty. It doesn't have any solution. We don't have any number that satisfies both inequalities at the same time. Okay, so these inequalities have no solutions. That is one example where inequality may not have a solution. How about if we are given like this, two inequalities, right? How should we understand this, or how should we solve this? Actually, that is equivalent to this inequality. That means 3x minus 1 less than x plus 5, and here, and x plus 5 less than or equal to 4x plus 14. Okay, we should understand this like this. So, because this, how do you read this? 3x minus 1 is less than x plus 5, and x plus 5 is less than or equal to 4x plus 14, right? So it's like this, 3x minus 1 less than x plus 5, and x plus 5 less than or equal to 4x plus 14. Sometimes to show there's a system, we can just use a brace here or curly bracket here. So if you saw the first part, x take to the left-hand side, 3x minus x, that is 2x, less than 5 plus 1, it is 6. How about the second one, x minus 4x, that is minus 3x, less than or equal to 14 minus 5, that is 9. One more, the first one, divide both sides by 2, x is less than 3. And how about the second one? Divide both sides by negative 3. So x is greater than or equal to, because we are dividing by -3. That's why we need to change this inequality sign. So here we have -3. What is it? It is x is greater than or equal to -3 and less than 3. So if you just combine them together, that means that x is greater than or equal to -3 and less than 3. So that means that all the numbers between these 2 points will be the solution. Or solution set is from -3 inclusive to 3, not inclusive. Okay, how many questions? Okay, that's our last inequality. And after that, we'll have some discussion and finish the class. Given that 2x plus 3 is less than 5x plus 2 is less than 3x plus 28. Find the smallest prime number x that satisfies the above inequalities, the largest prime number x that satisfies the above inequalities, the smallest integer x that satisfies the above inequalities. Anyway, sometimes you see here, you may know how to solve inequalities, but if you don't know about what we mean by prime numbers, right? Or integers or rational numbers. Usually students cannot answer this kind of questions because they have no idea about these concepts. And that's why actually when you're learning, we have to learn. I mean, we should try to learn everything. Otherwise, every time one piece will be missing. It's like puzzle, for example, let's say with small pieces, you're going to make a kind of house. Even one small piece is missing, you cannot complete your project or you cannot complete your house. It's something like this. Anyway, because here, to answer this question, we should know what is a prime number, right? And what is integer. In some examples, you will see that rational number, okay? So anyway, the first to answer these questions, we have to solve the inequalities. So actually, I just write them as the system of two inequalities, 2x plus 3 less than 5x plus 2. And here we have 5x plus 2 less than 3x plus 28. So we have to solve them together. The first one, 2x minus 5x, that is minus 3x less than 2 minus 3, it is -1. Second one, 5x minus 3x, that is 2x less than 28 minus 2, that is 26. One more step, divide both sides of the first inequality by -3. So x is greater than, because we are dividing by negative number. That is 1 over 3. The second one, x is less than 26 over 2. That is 13. So that means that here the solution is from 1 over 3 to 13. All the solutions are here, right? Or that 1 over 3 less than x less than 13. That is the solution. Now let's answer the question. In question A, it says that the smallest prime number x that satisfies the above inequalities. So what prime numbers do we have here? We have actually greater than 1 over 3. That is 2, 3, 5, 7, and 11. These are the prime solutions of these inequalities, right? So among these numbers, which one is the smallest? 2 is the smallest. So the answer is 2. Question B, the largest prime number, x, that satisfies the above inequalities. So among this, which one is the greatest? 11 is the greatest prime number. So the answer is 11. C, the smallest integer x that satisfies the above inequalities, right? What are the integer solutions of these inequalities? Integer solutions are 1, 2, 3, dot, dot, dot. Here we have 11 and 12. And it says the smallest integer, so the smallest integer here is 1. That means that you cannot show any number, any integer smaller than 1. That will be the solution of this inequality, because we are saying here that 1 is the smallest integer solution of these inequalities. Okay.
Which of why one is not prime?
Yes. What do you say, Arad?
If why we are not counting one as prime number?
Because the reason is, Arabs, when you're giving the definition of prime number, what is the definition of the prime number? It is a whole
It
number, or
can
it is a positive integer, or we can say it's a natural number, which has exactly two different factors. Okay, if you just talk about one, how many factors does it have? One has only one, right, itself. Okay, for prime number, it must have two different factors. That is one in itself. It's like, for example, 3 factors are 1 and 3. 5, it is 1 and 5. Then we call them a prime number. Okay, that's what. And
next.
another reason you may wonder why we don't actually take 1 as a prime number. Because 1 doesn't actually make much contribution to our, let's say, solving problems. Why actually we define prime numbers? We actually use this usually to factorize numbers, right? For example, let's say 8. How can I write as a product of prime numbers? So I can just write it as 2 times 2 times 2. So just writing 1 times anything, we know that 1 times a, right? A times 1 equals a. So just writing 1 here, we don't need it. We don't have to, because you can always write this. It is obvious. So including 1 as a prime number, it doesn't make any contribution. That's why also we don't define this as a prime number. Okay. Okay, Elshan and Eldar, Arad actually knows, I think. Also, you need to join the group, and I will send one more time, I think, this chapter's homework. Also, chapter 1 and chapter 2 homeworks are there. We can maybe reshare if you cannot see them. I think you can see all messages, okay? You should download it to your telephone or iPad or whatever it is. So you should try to do this, if possible, on A4 size paper, and using this camera scanner, and try to learn, try to use the camera scanner. It's very, very useful app and very easy to use it. If you sign with your Google account, your documents are always there. Even after 5 years or 10 years, you can see what documents you saved there. Okay. And also, actually, you can access these documents from any PC. You don't have to access only from your telephone. Okay. So that's it for now. Arat, after you submit your test 1, I will send you test 2. Okay, and we will continue like this. Guys, if you have any questions anytime, you can send
Okay.
it to me through WhatsApp. Thank you very much. I will see you on Friday. Okay.
Bye.
Okay. Bye bye, guys. See you on
Bye.
Friday.